This is EGME-331 Solid Mechanics Prerequisite video series. In this video, we'll be reviewing the topic of cantilevers. So what are cantilevers or cantilever beams? A cantilever beam has a fixed support at one end only. That means the fixed support provides three reaction forces. There's a horizontal and a vertical reaction force, and there would be a reaction moment. And these three unknown reaction forces can be determined using the three equilibrium equation, which would be your sigma f sub x equal to 0, sigma f sub y equal to 0, and sigma m is equal to 0, which are available for any rigid body. Now let's take a look at the shear force and bending moment diagrams acting on a cantilever beam. The shear force acting at any section of a cantilever beam is the sum of the loads between the section and the free end. And the bending moment at a given section of a cantilever beam is the sum of the moments about the section of all the loads acting between the section and the free end. So consider a cantilever beam, let's say AB, of length L, subject to a point load W at the end B. So a section XX at a distance of X from the free end B can be placed, and then the shear force at this section would be R sub X, which is equal to W, and the bending moment about this same section XX would be M sub X, which will be equal to W multiplied by X. So the shear force at the fixed support A can be determined by keeping the section at A, which gives the shear force R sub A would be equal to W, and the bending moment M sub A would be equal to WL. And this is based on the shear force and the bending moment diagram that we just developed. Now the bending moment of a cantilever beam is maximum at the fixed end, and it decreases to 0 at the free end. The bending moment as well as the shear force diagrams are determined for all possible combinations of loads, and that would help to design the cantilever beam for a specific structure. The load applied on the beam is a combination of the dead load as well as the live load. So as per the design standards when we perform the design process. Let's see some of the applications of the cantilever beam. So cantilever beam structures are used in several engineering applications. Some of the examples include construction of cantilever beam balconies. We could say the temporary cantilever supports, freestanding towers, construction of cantilever beams for buildings, and so on. So let's take a look at some of the advantages and disadvantages of the cantilever beams. The most important advantage of the cantilever beam includes the fact that they do not require support on the opposite side. So the negative bending moment created in the cantilever beam would help to counteract the positive bending moment that is created. Also, the cantilever beam can be easily constructed. On the other hand, cantilever beams have several disadvantages, including the fact that the cantilever beams are subject to large deflections. Secondly, the cantilever beams are also subject to large moments. And most importantly, a very strong fixed support or a backspan would be necessary to keep the cantilever structure stable.